Yeah. Wait, am I muted? How about now? Hello? Nope, not yet. Okay, I'm gonna restart the app. Okay, now talk. No.
Notice how it's not activated?
Yeah, it's not activating.
Keep talking.
Okay, can you hear me now?
Yeah.
Okay, I still can't hear you.
What? What do you mean you can't hear me?
The little.
Oh, okay. Now it's weird. I think you have to leave it up. Can you hear me now?
No.
No? See, he's picking you up here.
Okay, get the volume all the way up. Yeah, mine's not detecting. It's detecting me. It was detecting him earlier.
This is detecting him. Oh, wow. Okay, here. I just put my volume up. No.
I mean, it sees him.
It's not muted.
No.
I can hear you. Kind of weird. I'll restart muffle set.
Okay. That's fine. Oh, we're streaming the back deck. Cool.
And Megan, if you need to go, because they're.
Yeah, I'm watching them on the HD camera. They're just doing hot checks right now, which I don't really have to do anything. Wait, I heard him for a second. Like right when you first started talking, I could hear you, and then you went away. Well, that's good on one side. Okay. I'd have to repair. Yeah. Yeah, he's not activating on mine either.
Weird.
He's not. Yeah, he's activating his. Oh, this, yeah. Maybe he's got something going on in his setting. No, he's gone. Okay.
Hey, man. How you doing?
I'm doing pretty good.
It's-
Let's hope the connection stays.
Yeah, we're good.
Yeah. Okay. Yeah. All right.
Thanks,
No
Megan.
problem.
Jeff says thank you.
All right. See how this goes. Oh,
Yeah, this is yeah, this is amazing. Megan, can you hear me?
all right. Can you still hear me?
Yes, yes, I can hear you loud and clear. Can you hear me?
Yep, I can hear
Okay, great.
you. Okay. Yep.
So,
Fine.
so when this
So, hey guys, we're back. We had to deal with a few things. So, if you're looking at the video feed, what's happening right now is they are setting up for deployment. Maybe Kanisa or Bridget already went through some of this. It's going through what's called the A-frame, which is a big U-shaped crane. Those lines, they're just sort of establishing who's going to handle which line. Those lines keep the whole package from swinging. If you see the weather out the back of the ship, it's actually really calm today. It's really nice. The calm before the storm. Um, and the guys are just sort of talking through how they're going to deploy it. So the crane will pick it up. And the minute it comes off the deck, you have the potential for 2 tons of steel to be swinging around back and forth. So those lines keep it from swinging left and right as the crane then moves it outboard. Then they'll pull those lines off and settle the whole thing down into the water. So you'll see that in a few minutes. This is going to take a few minutes, so be patient, and we'll get there. And it's only 420 meters here, so once we do launch, we'll be at the bottom in like 10 minutes. Do you guys have any questions right now that Brian and I can answer? Can you guys hear me okay? Okay. I'm sorry, there's a lot of background noise here. Can you say that one more time? I'm sorry. Yes, I can hear you now. Yes, yeah. So at the very top of the A-frame is a block, a roller, and that's where the cable that is connected to the top part of the ROV, that's the connection there. So um, this will all become pretty apparent as soon as you guys see launch. Once we launch, then we'll switch camera over to the camera on the ROV itself so you can see the descent through the water column. But yeah, you'll see the A-frame go out, you'll see the block at the top, and the cable. The main cable has several electrical conductors in it, and it also has 3 fiber optic fibers, and it's about 3/4 of an inch in diameter. So it has a very high working strength of many tens of thousands of pounds. Um, and the fibers are what we are sending video and most of the data through. And it's extremely high voltage insulated cable to power all of the hydraulic and other of the winch room. The winch drum is about 9 feet in diameter and holds. I think this particular length of cable is something about 6,000 meters long. So it's many thousands of pounds of cable. So I saw a question on the chat. The descent's going to take about 10 minutes, maybe a little bit more, maybe 15. When we go out tomorrow to Station Aloha on the abyssal plain, the descent is going to take a little over 3 hours. So just another reason why the test dive location is shallow. A lot less time involved. So there was another question about modified plans. Yeah, so a number of you are local and you're very aware of Hurricane Douglas. Some of you are not, and so you may be hearing about this for the first time. But we have a hurricane headed at the Hawaiian Islands. There's a link in the chat that you can see the position of the hurricane relative to us. Right now, it is not affecting the waters around Oahu, but it is expected to do so on Sunday. We are hoping right now that our plan will continue. We will do our test dives today. We will go to Station Aloha and do a dive tomorrow morning, which will last most of the day on Saturday. On Sunday, we don't know, and we're just going to wait and see whether the track of the hurricane changes, if it blows up, hits the main Hawaiian Islands, or decides to shift a little bit more westward and skirt south of the islands or through the islands. We may not see many effects. But if it stays just north of the islands, we will probably not be able to conduct science for tides. So the hurricane is not threatening in any way to safety. It's going to stop our work because it'll be unsafe to do operations on the backpack potentially. So the captain is in charge of all safe aboard the vessel, and we have daily, and because of the hurricane, probably more than daily meetings to discuss what we can get done safely. We have to play it by ear. So another question is, what is the main goal for today? The main goal for today is simply to test the ROV system and to ensure that everything is fully functional so that when we dive tomorrow, all the way down to the abyssal plain, that we aren't encountering any technical problems with the system. So we will do the dive onto the seafloor at 420 meters. We'll check all of the communications.
I just had to come in here, I guess.
And we'll check all of the
I was in the van, and then all of
manipulator
a sudden
arms.
went out.
And
But it was working well.
we'll do the slurp sampler. Those of you, I think some of you saw the slurp sampler, which we use to collect things like anemones and sea cucumbers and stuff like that. And then we'll try to take tube pours of mud, and we'll also drive across the seafloor in a line in a transect to count animals. Not because we're so much interested in the data at the site, but we want to actually do all of the things that we plan to do at the abyssal site here, where we're in shallow water, where if we discover there's a problem, we're close to port where we can deal with it. The other thing is that in preparation for this trip, the team has to take apart some of the hydraulic components of the vehicle, and those have lots of flexible tubes and things of that nature, and they're filled with oil. And that oil gets pushed through those tubes and helps to move parts of the vehicle, like the robotic arms. Those have to be what's called compensated. So when you go down under pressure, there may be little bubbles all throughout those lines of oil, but those all get squeezed by the pressure. And before you know it, you don't have enough oil in your system. So the other goal today is that we'll drop to 420 meters. It'll squeeze lots of the air bubbles. And then when we come back up, we'll fill up with more oil and sort of top off those reservoirs. And then we'll do 2 dives today. We'll do one, we'll come up, we'll top off oil, and then we'll do another one right away. And that way, when we get out the abyssal site again, that's one less thing we have to worry about when we're on station and ready to do the full science. So. Sorry, somebody was saying something, but I had difficulty hearing. Uh-oh, everybody's frozen. Zoom just gave out. Oh, what's the most exciting thing? I love it. Oh, okay. Sorry guys, we have a bit of a blind spot with our satellite antenna, and and it goes behind the smokestacks of the ship, and it blocks our path to the satellite. So they're realigning the ship so that we don't drop out again. Hey, Megan, can you hear me? This is Jeff. Uh-oh. Is this thing? Hello? Hello? No. I'm sure they're going through all their checks in the control room, but I thought they'd be launched a half hour ago. Yeah, we're up. We're up. No worries. Hey, Megan, can you hear me? This is Jeff. Yeah. Hello. Hello. Got it. Cute. Okay. Hey, folks, this is Jeff. They're just getting, we got our satellite back. If you looked at the video, we are launching right now. They're taking down the safety gate behind the A-frame. People are getting into position, and we're going to put this thing over here in just a minute. So you can see the people on the left and right of the vehicle, and they're handling those lines. There'll be one person coordinating the effort with the crane. Here we go. It's coming up off the deck. And the A-frame is now leaning out over the water. You guys may have a bit of a delay between what I see and what you see. You can see it swinging just a little tiny bit right now, which is Not bad at all. It's super calm today. Yeah, that's going to change dramatically. So the guy in the blue hat is the one calling the shots, and he's talking to the crane. So the hand signals are for the guy that's operating the A-frame and the winch. That's called the tether management system, or TMS. Sometimes we call it clump. And it's a large piece that the ROV undocks from with a very soft tether between the two. And then when the ship heaves up and down, the TMS goes up and down, but it takes away the motion from being translated to the ROV itself. So that TMS also has a downward-looking camera on it, and so you can actually see the ROV on the seafloor if the TMS happens to be directly over the top of the ROV when they're separated, which does happen. And it also just provides a hub for some of the splitting out some of the fiber optic communications that go into the ROV. Okay, so the safety gate is back up, and I'm going to go ensure that you guys have got the right video feeds. So I'm going to sign off for just a minute. I'll be back, and then you should start seeing video from the ROV itself. Hey, Megan. Hello, this is Jeff. Megan? You know which one it is? Isn't it input or a channel? Okay.
Can you hear me, Jeff?
Yes, I got you, Megan.
Awesome. Yeah, I keep losing some connectivity, but
Yeah, there was a satellite that we got blocked by the stack, and it's back now. They pivoted the boat a bit.
Okay.
We're back, and we're gonna. Trevor is just setting up the video so we can see the main ROV cam, and then we'll switch that on the live stream.
Sounds good.
Okay. Everything looking good on the ROV thus far?
So far, it looks good. We are bringing cameras up now.
Okay. Apparently, can he switch to the ROV HD cam? Oh, there it is.
Yep, there it is.
Okay, we're good.
All right, so
Great.
today's dive is dive 126.
Yes. Okay.
And we're going to be going down to about 420 meters, so it should only take a few minutes to get down there and enjoy. Going through our startup procedures.
Sure. Maybe we can put that on the live stream.
Where's
Sort of. There are certain squid that are attracted to the lights on the ROV. And I've actually seen Humboldt squid off of the Gulf of California hunt at 2,000 meters depth using the lights of the ROV and attacking fish. But there's also a lot of animals, particularly when you get deeper down, that uh, see all the light and the noise as a giant predator, and they go the other way. That's, of course, a whole lot harder to show, but typically what you see is that just on the edge of your So piloting the ROV, there's one of the technicians and Blue Eisen, um, and they are trained. They're really good at video games, apparently. Have they have the ability to drive this thing around. It's pretty big. It's responsive. It has a number of different controls and thrusters, but it's not straightforward. You need a lot of experience to vehicle to move where you want it to go. There also is a person sitting next to the pilot in the control room, and his job is really to operate the robotic arms, and that takes a lot of skill and dexterity. First of all, because you are looking at a computer screen and you're trying to manipulate things in 3 dimensions, but you only see the flat screen in front of you. And so it's really hard to know, you've got these jaws out in front, you're trying to pick something up, and you know what looks like is something aligned, some object, picking it up with the jaws, you end up doing this, and you miss it. And so it takes a lot of experience from the guys who operate those, the bottom of the ocean. We very much take for granted our So virtual reality is going to change the whole ROV driving operation experience. They're coming up. It is the arm on the port side has fewer articulations in it. It's not quite as dexterous as one on the other side. Probably just reflection in the dome right now. So we're not on the bottom yet. Yep. So what they're going to do, this because this is a test dive, is at stages on their descent through the water column, they'll stop and they'll operate a bunch of the different machinery just to make sure that everything is functioning, despite the fact adding pressure. And hopefully then there are no issues by the time we reach the bottom. So there was a question, did they collect any data during the event? So video is recorded, and that is definitely data. And then there are also some navigational sensors, the location of the vehicle, the depth of the vehicle, the salinity of the seawater around it, its temperature, oxygen concentration, and all of those data feeds are being recorded from the moment the vehicle enters the water until it exits the water. So sometimes yeah. Yeah, we probably won't actually collect any animals and bring them back here, but the real goal of today is just to completely test the vehicle. So we will take a push core, but we'll probably shake out the mud be here, so it'll probably fall out on its own. We will try to pick things up, but instead of picking up animals, we'll probably pick up some rocks. And actually, the site that we're visiting used to be a past dumping ground for the Navy, and so you find things like bottles and coffee cups and stuff like that. And so sometimes we called like 19 across the seafloor. We'll do everything that we would do on the abyssal plain. We'll do it here on this test dive. Yeah. Kanisa asked a very good question there. You guys have to stop me. Science is full of jargon, and sometimes we forget we're even using it. So I use the word transect. Raise your hand if you know what a transect is. A couple of you. Okay. So when I use a word that doesn't make any sense to you, please call me out on that. So I just and you know how many sea cucumbers you counted and how many brittle stars, and so you can estimate the density of all those animals. How many animals per square meter are there in this area on the seafloor? And that's what we're talking about when I use the word transect. So it's just an animal survey, and you can survey anything with a transect. It's just driving in a straight line. So
Oh, maybe that's it. Oh, that's the wrong mouse. Not on this. On this. Okay. This one. Disconnect it. Okay. No, Steve usually like kicks us over, and I've never learned.
6 more minutes. All right, no, more times. 12 minutes. 12 minutes. Yeah. Okay.
It says parameters. Oh, sensor.
Um,
That's
okay, I see now in the chat. Yeah, so does depth cause delay in the hydraulics? Yeah, actually, it's really interesting. I'm not an engineer, so this answer is really from a biologist. But when things get colder, when that hydraulic oil gets colder and you add pressure, it becomes viscous. It's not oil anymore. It turns into syrup. And depth that you're going
I
to.
don't know if
So
I'll
they
be
make
able to
different kinds of hydraulic oil
text.
that
Don't
have
have an
different viscosities. So they're actually on the test dive using oil that's meant for super high pressure and very cold temperatures because they don't want to change it out between this dive and our dive at 4,700 meters tomorrow. But yeah, you have to tune that oil so that your hydraulics work properly. So today we're only at a depth of 420 meters. So
I
a
don't have
tenth
his
what
number.
we're actually going to do science at. So we're dropping at about 25 meters a minute right now, and that means we're going to be in the seafloor in about 10 minutes. We have some of the lights on, but probably not all of the lights are on right now. And in terms of visibility, it's very hard to gauge. So our depth of the ROV right now is 195 meters. So
Right.
the light is diminishing rapidly. Your dark adapted eye can actually see at this depth, believe it or not, just not very far. And we have a bunch of lights off. But
they're all facing down.
so once we get to the seafloor, the light environment will change a lot. We're going to turn on more lights, but also light will be able to bounce off the bottom. And that's going to light the whole environment, the whole scene in a way that you don't get in the open water. And so light just extends out into the horizon, and it gets difficult to see in midwater. Yeah, actually, I'm looking at the video again. There's a lot of particles here today. More than normal for sure.
It's not
A lot of
Yeah,
those
that's
are particles
I can't do anything because there's it's
right.
not connected, and I don't
Being
know.
still going up. Particles.
Mm.
Yeah, sure. So, our project is a food web project. We want to know what sorts of food are reaching the deep sea floor on the abyssal plains. The abyssal plains are between 3,000 and 6,000 meters in the ocean. They're typically fairly flat, and they cover half of the surface of our planet. They're huge. And in the few places where we've been able to study this environment, this type of environment, we can measure all those little particles you see in the video. We're descending rapidly, so it looks like they're moving up. Normally, all those little pieces of flock, they're things like dead phytoplankton and the poop from zooplankton. We're missing something. The animals are living around. We think there are smaller particles, smaller than the ones that you're seeing in the video right now, and those little funnels, they don't catch those particles, those really small particles, very well. I mean, we're talking things that are like less than 20 microns in size. They're the size, and they do slowly sink. And so we're going to try to collect particles, not with the ROV, but with some other instrumentation, these pumps that filter water. And the really tiny particles have distinct chemistry, have signatures associated with them, associated with their stable isotopes, which I'll let Brian talk more about. But so we can measure those particles, those really tiny, paying attention to, and we can try to trace whether they make it into the animals that live on the seafloor, because we can measure the isotopes in those little tiny particles. They're different than the isotopes in the big particles that you can see. And then we can measure all those isotopes on the sea cucumbers and brittle stars and things on the bottom, and the fish and everything else. So that's the goal. We got to collect food, even the food that people didn't think was food before, and we got to collect some of the animals on the bottom, and then we do a whole lot of chemistry. And we basically trace those different particles into the animals. Find out what are they eating? What's the important nutrition?
Yeah, to us, large particles, like small particles, five, to give you a sense of what that your hair, the width of your hair is about 150. So they're really tiny, the smallest. We
That's 1,000 microns. So
can learn about
Okay, we're stopped right now.
Start hitting. Just a second.
Yeah, we are currently at 320 meters, and they're doing a couple more checks, and then we'll continue our descent. We're almost there, 100 meters to go.
Can you see the manipulator arm moving on the video?
And you guys see the lasers as well? So I think Brian and I only told one group about what the lasers are. So those are parallel to the camera. And so you can point the camera anywhere, and those lasers are going to be 10 centimeters apart. So they're like a ruler. So you can point at any object, and you can get the size of them wherever they go. Yeah, there's a baseball in the field of view there, so you get an idea of the scale. This is still just like this. So I'm muted now? Nope, I'm still talking. Am I muted now? Say again. Yes. Can you hear me, Megan? Yeah. I cannot hear you. No.
I don't know why continuous wasn't working.
Okay.
Can you hear me now?
Okay.
No, I don't think continuous is working. I'll have to figure out why. On stream and see if it's cutting out still.
Okay.
Yeah, I hear you guys now.
Okay, good.
Sounds better.
Yeah, I can hear you. Yeah, I couldn't before, but
All right, that works.
thanks, Lance. At this rate, I don't know that we're going to get 2 dots, but okay, they're undocked. No, they're not. Oh, for a second I thought they were undocking, but they are not. Yeah. I missed it. What was it? Yeah. Okay, got it. Yeah. Hey guys. Rachel, sorry to interrupt you, but I just wanted to bring to everybody's attention we're at the bottom. So there's some garbage there, and in front of it, just in front and to the left, you can see a small fish with a long eel-like tail. That's a rat-tailed fish. You can see that when we touch down, it looks like a little bit of mud got kicked up off the seafloor. The sediments are really fine on the bottom. That's actually not that bad a cloud of mud to get kicked up. So one of the first things they're going to do now that they're on the seafloor So you can see there that chunk of mud. You see how it just stuck together when they dropped it back on the seafloor? So in the deep ocean, a lot of the sediments are really fine, so that you can think of it almost like clay. So what they're trying to do is orient so that they're faced into the currents, so that if we make any disturbance on the seafloor, all the mud flows behind us and doesn't obstruct our field of view. So you always want to be faced into the current when you're doing your work. So that little thing swimming in front of the camera there just a moment ago, that was a krill or a euphausid. And that little fancy.